This is lesson 3.5, graph lines using slope-intercept form. So in this lesson, we're going to learn about slope-intercept form and also how to convert from standard form to slope-intercept form and to use slope to determine if lines are parallel. So we're also going to learn how to use our graphing calculator and how to type in an equation to look at the graph using our graphing calculator. So at this point, I would like you to pause the video and make sure that you get your graphing calculator out so that you can follow along. It's really important to follow along so that when you're doing the problems on your own later on, then you know the steps. All right, so let's get started. So part 1 says to write a rule for the table of input-output values. All right, so the x is going up consecutively, so it goes 1, 2, 3, 4, starts at 0, and then the y goes 1, 1 and a third, 1 and 2/3, 2, 2 and 1/3. So whenever you look for a pattern, look for how much you are increasing or decreasing each time. And if there's a constant amount, then that means we can write it as a linear equation. So this would be adding 1/3 each time. Okay, but you can't just do y equals 1/3 x, because 1 times 1/3 is not 1 1/3. So what we have to do is we have to also add 1. So if you plugged in 0 for x, you'd get 1/3 times 0, which is 0, and then plus 1, which is 1, which is what the y value is. What if we plugged in 4? Or let's look at 3 for an example, because 1/3 times 3 plus 1, 1/3 times 3 is 1, plus 1 is 2, which is what you get for the y value. All right, so this would be the function, and this is what we call slope-intercept form, which is y equals mx plus b. Slope-intercept form allows you to see the slope and also the y-intercept. So notice at this point here, when x is 0 and y is 1, that's the y-intercept, because the y-intercept is the point where x is equal to 0. So you've already seen this in the past lessons. We've been working with this form, this equation of a line, y equals mx plus b. So today we're going to learn more about it. All right, so now we're going to do a little exploration with your graphing calculator. So part A is press the y equals button at the top left and clear any equations that are already there. So open up your calculator, and the y equals button is right here, so click on that. And then if there are any equations here, you need to just press the clear button. Okay, so you shouldn't have any equations. Also, the plot 1, 2, and 3 should be unhighlighted. So for example, if your plot 1 is highlighted like that, you have to hover over it and press enter to unhighlight it. So you don't want your plots to be highlighted, or else it'll give you an error message. If you experience any other problems with your calculator, just ask me when you come to class, or if you are an e-learner, just shoot me an email if you can't figure out how to get your calculator to work, or if it's giving you some kind of error message. Tell me what the error message is, and then I can tell you how to fix it. All right, so the next directions here say type in the equation for y1, 5x minus 3, for y2, negative 2x plus 6. Maybe I'm going to try to minimize this. All right, so 5x minus 3. And the x button is right here by the green alpha button. And then negative 2x plus 6. Negative 2x plus 6. Also, make sure that you differentiate the minus sign from the negative sign. The minus sign is right here. The negative sign is down here by the enter button. Okay, so now we press zoom 6, and you should see both graphs appear on the screen. So press zoom and then 6. You can either scroll down to 6, or you can just press the 6 button. That says standard. That gives you the negative 10 to 10 window. So as you can see, it goes from negative 10 to 10 in the x, negative 10 to 10 in the y. So here are both graphs. Now if you have a color-coordinated calculator, then when you go to your y equals, the first one will be blue and the second one will be green, or whatever other colors are in your calculator. So this is the first equation, this is the second equation. And this makes sense because in the blue equation, the slope was positive, and then the red equation, the slope was negative 2. All right, so what is the y-intercept of y1 and of y2? So the y-intercept of y1 is negative 3. The y-intercept of y2 is, this is 1, 2, 3, 4, 5, 6. So negative 3, or we'll write it as a coordinate, 0, negative 3, and then 0, 6. Both equations are in slope-intercept form. What connections do you see between the b value in the equation, so negative 3 and 6, that would be the b, and the location of the y-intercept? Well, they are the same. So the b in the equation is the y-intercept of the graph. All right, so next, we're going to press second table. So it's the blue above graph. So go back to your calculator, press second. So this is blue button, and then table. So table is this button here. So we press second graph to get to the table. Okay, so now your calculator should start at 0, and then you'll see all of the table for the y1 and the y2. So let's see, what does it say next? You should see the table. Also, if your numbers don't match up with mine, it's probably just because you typed in the equations wrong. So go back to the equations and make sure that you type those in correctly. So you should see tables of values for both equations. What connections do you see between the increase and decrease in each step of the table and the m value in the equation? So if we look at the blue equation, we're going up by 5, okay? And then if we see the red equation, we're going down by 2. So up 5 and then down 2. Well, they're asking you, how does that compare to the m value? Well, the m value in y1 is 5. The m value in y2 is negative 2. So once again, they are the same. So the increase or decrease in each step of the table is called the slope. So the slope in the table is the m in the equation. And if it's negative, that means it's decreasing. All right. So in summary, in y equals mx plus b, m represents the slope of the line. So whether it's increasing or decreasing. And then b represents the y-intercept of the line, at the point where the line crosses the y-axis. This is 0, b. And it's also the starting position when x is equal to 0. Create an equation in slope-intercept form. Circle the slope and box the y-intercept. Okay, so you make your own equation. You can pick whatever number you want for m, whether it's a fraction, negative number, and then whatever number you want for b. So I'm going to make an equation, y equals negative 1/2 x plus 2. Now, for my equation, you can pick a different equation. Is my equation increasing or is it decreasing? And ask yourself about your equation. So since mine has a negative slope, it would be decreasing. So I'm supposed to circle the slope. So there's my slope. And then here's my y-intercept. Okay, and then another question, does it start below or above the x-axis? Well, since my y-intercept is 2, that means it's going to start above the x-axis when the y is equal to 2. And then whatever your equation is, you can answer those same questions, or you can ask a neighbor to answer the questions and see if they're correct. You can kind of quiz them on it. All right, so let's do a few examples. So here we're going to learn how to convert from standard form to slope-intercept form. So here we're going to convert each equation to slope-intercept form. And we have done this before already. So if you remember when it said to solve for y, so that's what we're doing here. We want to solve for y. So in this equation, all we need to do then is to move the 3x over. Okay, so then we would have y equals, and if we write it in slope-intercept form, you want to write the x term first. So we're going to put negative 3x first, and then plus 2. Okay, identify the slope and the y-intercept. So the m is negative 3 in this case, and then the y-intercept, since it's 2, would be 0, 2. Okay, then here's how we graph the equation. So in order to graph, step 1 is you plot the y-intercept. So our y-intercept here is 0, 2. And then step 2 is to use the slope to plot another point. And then step 3 would be to draw a line between those 2 points. All right, so since our slope is negative 3, we can also think about that as negative 3 over 1. So we would be going down, from this point we would be going down 1, 2, 3 over 1. Since it's negative, your slope should be going down. So and you can also make more points, 1, 2, 3 over 1, or you could go up 1, 2, 3, and then to the left 1. The left would be the negative part. Okay, so then take your straight edge and draw a straight line. Well, all lines are straight. Draw a line between those 2 points and put arrows at the end. Now with edge elastic, you only need to make 2 points and it'll automatically make the arrows for you. All right, so let's pick another one that is harder. Let's do number 2. So in this equation, we would need to first solve for y by subtracting the 3x over. So then you have negative 3y equals negative 3x, because you write the x term first, and then plus 12. Now remember, at this point, you're not done. You need to take whatever is being multiplied by y and divide each term by that number. So here, we're going to divide each term by negative 3. And then you're also not done here. You have to simplify each of these terms. So this is going to become y equals, and this is going to come negative 3 over negative 3 just becomes positive 1, so just x. Okay, anytime you have 2 negatives, they need to cancel out. And then here, you have 12 divided by negative 3, which is going to become minus 4. So here, the slope, m. There's no number in front of x. That means that there's an invisible 1. So we would put 1 for the slope, or you can say 1 over 1. And then for the y-intercept, that would be negative 4. So 0, negative 4. So remember to graph. The first step is to plot the y-intercept, which is 0, negative 4. And then you would use your slope to get another point. So you could go up 1, over 1, up 1, over 1. Okay, this is what we would call a diagonal line when it has a slope of 1. You can go down 1, over 1. Okay, you don't have to make all of these points, but at least make a couple. All right. So at this point, I think you have enough examples. Maybe we'll do just one more quick one. How about number 4? So number 4, first move the x term over, because right now it's in standard form. We want to get in slope-intercept form. So then we would have negative 3y equals negative x plus 9. Okay, now divide everything by negative 3. And then you have y equals. Now here, you have negative over negative, so that comes positive. And then you have x over 3. Now, the over 3 is going to come out as 1/3 times x. So that's how I want you to write it. Anytime you have a fraction, pull it out as a fraction in front of x. And then 9 over negative 3 is going to become minus 3. Because 9 divided by 3 is negative 3. All right, so here your slope is 1/3. And then your b value is negative 3. So we would plot negative 3 on the y-axis, and then a slope of 1 over 3. So go up 1 over 1, 2, 3, up 1 over 1, 2, 3, and then we could put a point on the left going down 1 over 1, 2, 3. All right, so that's all the examples we're going to do in class. The rest of them you will do in the Elastic assignment. And that is all for this lesson. Have a great day.